Operational workflows break monolithic AI models. Feed a single large model too many tangled multi-step data streams, and the system eventually fractures under the load. When a single model context switches between research, risk management, and execution, its internal logic often blurs. Without structural boundaries to separate these roles, the system produces inconsistent outputs that compromise governance. To solve this, Llama Research built Project Cortex. It is a multi-agent system engineered specifically for mechanical, risk-managed operational execution. Instead of one model, Cortex operates as a digital org chart of 9 specialized agents. CEO and CIO orchestrators set priorities. Directives flow to macro and event sentinels scanning data. At the base, monitor and execution risk agents enforce rigid, programmed boundaries. Together, these 9 bounded agents run over 40 scheduled jobs continuously, executing complex workflows around the clock without a human needing to monitor the screen. Reliable autonomous execution is built on divided labor and narrow, bounded agents. This structure enforces a level of consistency that generalized probability engines struggle to replicate. Every decision in Cortex starts at the intelligence core. This is the foundational machine learning model that generates the system's baseline probability scores. It continuously ingests real-world data, specifically tracking the price and volume metrics of S&P 500 constituents to ensure its signals are grounded in highly liquid equities. Layered on top of that raw pricing data are secondary streams, including broad macro regime features and real-time sentiment signals. The core retrains on a nightly cadence to absorb new market data. But execution reliability requires strict model lifecycle management before that logic is deployed. Before an update goes live, it must pass a strict quality gate. If new logic fails baseline thresholds, the system blocks deployment. When a check fails, the previous version remains. A proven model is never swapped for an untested one. A production-ready AI system must mechanically validate its foundational predictive logic. If it cannot prove its reliability, it is not permitted to generate a single operational signal. Once a validated signal is generated by the core, it is handed off to the multi-agent orchestration layer for review. It hits the strategic direction tier first, where the orchestrator agents weigh the opportunity against the daily priorities and overarching system goals. From there, it passes to the macro researcher agent, which scans for hostile broader market conditions that might demand a defensive posture. The sector researcher agent then takes the signal, analyzing localized fragility and factor crowding to ensure the trade isn't structurally weak. Finally, the event sentinel agent scans the calendar for upcoming event risks, like an earnings call or economic report, that could abruptly invalidate the thesis. These checks are just a fraction of the process. In total, the signal runs a gauntlet of over 40 continuous scheduled jobs across the network. This 3-tiered stack powers the orchestration. The base layer uses signal models for heavy predictive mathematics. The middle layer uses large language models for complex reasoning and agent orchestration. The top layer uses local open-weight models for low-cost inference, keeping overhead strictly controlled. Engineers call this multi-tiered architecture intelligent model routing. It ensures the right computational tool is used for the right job at the right cost. Project Cortex defines autonomy through perfectly orchestrated, deterministic collaboration across a highly optimized technical stack. Even if a signal clears the intelligence core and the agent network, it is not allowed to act without clearing a final multi-layer gate stack. A payload drops into sequential operational gates, clearing signal quality. It passes macro regime, which approves market conditions, and clears positioning. But at the event proximity gate, a news conflict is detected. The layer instantly flashes red, destroying the payload and resetting the stack. This architecture operates on the fail-closed principle. When in doubt, the system does nothing. If data is missing or delayed, the system does not make a calculated guess to fill the gap. It simply stands down. A single flagged conflict across any of the 6 gates defaults the entire pipeline to total inaction. If a signal survives all 6 gates, it does not execute. It becomes a decision card, waiting on the defining constraint of the platform. Propose, don't deploy. No agent is permitted to touch the production system. Every single decision card requires explicit, human-in-the-loop sign-off before anything moves. Once a human approves, the execution fires as a single atomic action. There is absolutely no partial deployment allowed, and downside risk is mechanically bounded from the start by a high-water tracker circuit breaker. A production-ready operational AI requires a heavy engineering focus on its capacity to safely refuse action. Every successfully executed atomic action feeds directly into the next phase of the Cortex pipeline, a closed learning loop. Context and market conditions of every execution are immediately logged into a forward test ledger. That data flows back to the intelligence core. During a weekly retrospective, the system mechanically grades itself, comparing predicted confidence scores against actual outcomes to evaluate what worked. This closed-loop grading applies strict MLOps discipline directly to operational decision-making, ensuring the system gets sharper after every action. This underlying pattern extends far beyond financial markets. It applies to any industry currently relying on legacy spreadsheets, lagging outdated reports, or gut instinct to run operations. A robust system requires 4 pillars: a single source of truth, fail-closed logic, hierarchical accountability, and propose don't deploy constraints. Meaningful enterprise modernization requires embedding governed, multi-agent pipelines deep into core operations.